I gave myself some honorary names. I find them to be super applicable. Dr. Professor Great Evan, the Great Carroll, PH, double D's. It was, I needed to, I was on Stack Overflow and they had a guy that was German, and in Germany, it's actually the normal standard. If you are a doctor and you teach, then you go by Dr. Professor. So he jumps into one of the questions I have, changes his name to Dr. Professor, and then we get into this little, it's sort of just been a technical dispute. So then I changed my name to Dr. Professor, and then this whole entire kerfluffle on Stack Overflow comes up about, changing your name to honorary suffixes, and I'll be Dr. Professor today. All right, so I wanted to recap about the what we've done in the past, because we're making a lot of progress here, and we are going to start off this chapter talking about some more sophisticated data structures. So we need to know what we've already covered and how they can kind of like fit into that role and what we're going to be using these things for. So chapter 2, we covered flow control, right? Flow control was very basic. It was things like if statements and booleans and those kinds of things. We went over for loops and while loops. We covered things like break and continue, right? How do we get out of the loop? How do we restart the loop? All of those types of things. And we covered this notion of blocks, right? With Python, you indent, you create a block. Now that block doesn't always mean the variables get stuck there. It has different meanings with Python. But let me make sure I'm screen recording this. Yes, I think I'm screen recording this. Okay. Because Python uses those blocks to identify where the loops start and stop. So you indent and you remove those indents to say this is still part of that loop. And in chapter 3, we covered def statements, and def statements are going to essentially we use those to create a function, right? So Ed took over on that class, and Ed went through what a function is and how do we create our own functions and how do we use functions, how do we pass arguments into functions. When we pass those arguments into functions, if we change them, do they reflect in whatever called the function? Does anyone know what I'm talking about? Right? Does that make sense, or do I got to show some examples, right? Let's take a look at it. We're going to come down here, and I'm going to say, I have this open. We're going to open one of these. Make it big so you can read it. Python 3. Okay, let's say I have a variable and I say a equals 10. And I create a function, and I say def, we'll say increment. And it takes a variable, right? It takes an x. And what I'm going to do here is I'm going to say x equals, x equals x plus 5, right? And then I'm going to return x. And now if I say increment a, right? Is that a going to be, what is that a going to be after I run this function? This was all that, this is the stuff that Ed covered in the last class. 15. It's going to be 15?
It'd be 10, right?
What is a going to be? Okay, let's run it. Here we go. Increment a. We get back 15. But now what is a?
Okay.
A is 10, right? So that's one of the things that we covered in the last class. Does everyone see that? Because we've got to understand it. That's all that scoping thing, right? So Ed definitely went into that. What we're doing here is we're taking a variable and we're passing it into a function. But that variable that we passed into a function, when we modify that variable inside of that function, it has a whole different scope. It doesn't touch the outside variable, right? Because it's getting its own copy of a variable. So Python passes by copy. We pass in a variable into increment, gets its own copy. You can do whatever you want with it. You can return something. But the end result is that a doesn't change, not modified, right? Okay. So we covered that in the last class too. So this class we're going to pick up, and we're going to be talking about lists. Slideshow, start from current slide. So lists hold 0 or more things. So far we've talked about variables in Python, and we said those variables could be of 3 different types, right? Does anyone remember what those types are? I'm going to start calling out people so we all stay awake. Let's go with Jonathan.
I remember one was none type.
That was definitely one of them. That's the tricky ones. That's the 4th type. So let's move over Marcel. Give me a variable type in Python.
Integers.
There we go. Boom. Dan.
String.
String. One more. What was your name again?
Travis.
Travis.
Boolean.
Boolean, that'll work. But we had one more that, what do we call it if it has a period in it?
Float?
Float. Boom. There we go. Okay, so we have all these different little things in Python. These are different ways we store data. But so far, they only store one little piece of data, right? It's like an atom. You know, it's hard to build a car with just atoms. So we have in Python more complex types. They can hold multiple different pieces of information. So now we're going to be talking about some of those complex types in today's class. One of those complex types is called a list, right? And this is what we're going to kick it off with. This is most of today. A list holds 0 or more things, right? So we have a none type, which tells you that that little atom has got nothing in it. It's a special type in Python, right? It says, hey, I'm empty, or there's something that I'm not. You may normally store an integer in here, but right now I don't have an integer. That's what none is. It was a special type. Okay, well in Python you can have an empty array, an empty list rather, and that empty list is going to have nothing inside of it, right? So don't let that throw you off. A list is 0 or more types, right? 0 or more things. So both of those are there. We talked about how we have 0 in the very first class. We have this 0 guy right here, which is the integer 0. We have this, which is the string 0, and this, which is the float, 0.0, right? Those are 3 different types. You can store all 3 of those in the same list, right? So we have these lists, and we can also have lists within a list, So I wanted to show you right here. This is what I'm getting at, and I like this slide. I thought it was actually clever. We look right here, right? We're looking at a list. If I was to ask you what this was on this PowerPoint slide, everyone here would say it's a list, right? Convenient, because that's exactly how you store something, or you could store something like this in Python. Element 1, element 2. Oh, element 2 has got its own list inside of it, right? So we can store that. I'm taking the first letter of each different word, right? And I'm actually, of each different point, and I'm modeling in a Python list. Hold is the first word, right? The first sentence. Then we have can, and now we have 3 things here. Well, how are we going to store 3 things? It's something that only stores one thing. You store another list inside of it. Of, recap, and this are all these. Of, recap, and this. Now we have one more element in the back. How are we going to store it? This, right here, in another list. That's how we can model more complex data structures inside of Python. We can start to do complex and cool things, you know? Okay, moving on. Chapter 4, lists. How many people here, show of hands, read the chapter beforehand? Oh, it's looking good. So the class is thinning out, but this is a devoted group. We lost the losers that didn't care. I like that. Okay. They weren't enthusiastic enough to learn. Yeah. And everyone that knows me is in the back, like, don't encourage them. Yeah.
Everyone looking like that.
The first version of this, I tell you, it was political. And then I was like, this is going to get me in trouble. And I actually have a job application in the cPanel. So I toned it down a notch. And it's sad because I actually made automate the boring stuff with Python political. But we have here the list data type, right? We're going to go over, this is very simple. And we don't really need to, because complexity comes later on. You don't start off with it, right? So in this first list, we have 1, 2, and 3. This is a Python thing, right? It's just like every variable stores something. Right? That's the purpose of a variable. This variable is storing a container. Inside of that container, there's 3 things, 3 integers, 1, 2, and 3. That's how they look in Python. All right, so we start off very simple. Here, we have the same container, this list container. It's storing strings inside of it. Cat, bat, rat, and elephant. Here we have one, and this is kind of cool, and this is important to note. We had people in the earlier classes that had some experience with other languages, right? So here we have the same container, this list container, and we have different types of things inside of it, right? In my example, when I did the slideshow, and I went through and I showed you all the bullet points, all of those were strings. But here we have string, number, Boolean, none, and 42. They're all in the same container. In Python, that list container is not strictly typed. You can put whatever in that you want. So it's important to observe that. Spam. I don't know why we're always going to spam and bacon with this class, but geez, it's quite concerning because it's the meat that's known for being cheap. So here we have spam It's got cat, bat, rat, and elephant in it, right?
Yes.
An interesting assortment of animals, right? And that is quite literal. I buy that, you know. When I was a kid, someone told me that that McNuggets had kangaroo meat in it, and I called bullshit on Santa Claus pretty quick. I mean, I was like 3.5 when I figured that one out. The kangaroo meat and chicken McNuggets, that took me to like 10. And this stuff doesn't taste like chicken. I don't know what it is. So here we have getting individual values in a list with an index, right? So we have all these things in this container, and we can access them all individually. You don't always have to treat this as one group of things, right? We can actually access each individual element inside of that container. And here's how we do it. We essentially put the same type of brackets, right, at the end of that variable, and then we can access those individual elements based on where they exist in that list. So what does that tell you about a list right then and there? Because this is the first revealing fact about a list. That lists are positional, right? The order in which you put things in a list usually matters. Not always, but quite frequently it matters. Lists can be sorted, right? You can push things at the end of a list. You can push things at the beginning of a list. All of these types of things are things you will do with a list. And when you do them precisely because the order matters. So because the order matters with the list, usually, you can access things with that index is what we call it, which is the number that represents its position inside the list. Okay, so we have these things, these containers, we can access individual elements in them, we can throw all kinds of crap in Python into these, right? Let's see what other things we can do with them. We talked about in the first class, I said, you know, when you have 5 plus 3, everyone knows what that means, right? 5 plus 3 is 8. It's simple, it's addition. Everyone's used to that. But if I say apples plus oranges, it's not as simple. But you can still kind of look at it and make sense out of it, right? We come here and I say apples, right, plus oranges. I'll remove the space. Okay, what is that going to do?
Concatenate them.
Aha, someone actually used the right word. But everyone else is like, I remember that paper shit you did early on. It's going to stick them together like glue, right? So yeah, it's going to concatenate them. That's the computer name for sticking things together, right? So it's not actually adding things like numbers. It's just meshing them together. Well, lists are containers, so does it make sense to add lists together? Yeah, right? And in that context, you can add lists to other lists. So if I had a list, right, that had 1, 2, 3 in it, and I wanted to add another list that had 4, 5, 6, what am I going to get? 1, 2, 3, 4, 5, 6. That's it. So you can take lists and you can add them to other lists. It's very simple. If I have a list that has 1, 2, 3, and I try to add something else to it, like 4, what am I going to get? Anyone want to give it a shot? Come on, someone shout something out. If it's wrong, we'll all laugh at you and it'll be over.
5
Type error, right?
An exception. We're going to get an exception, right? We're going to get an exception. This is what I'm saying. These are just things you got to learn about a language. So you may think to yourself, oh, well, if we can stick 2 lists together with an addition sign, why can't we stick a list and another number together? You just can't, right?
What if you multiply it by 2?
Oh, yeah, that was... Yeah.
I'm not saying there's definitely things you can do with them that make sense, but the idea of concatenation, right, with a single element does not work with a list, right? So you just got to learn these types of things. This is all about learning Python, right? So there's a way you can extend a list. You can extend it by adding another list to it, but you can't extend a list by adding a single element to it, right? Okay. All right. So we've got these lists, and we can add things to them, right? We have a string here. Let's take a look at this one. This one's kind of cool. What is going on with this, and how is it different from our example? Let's see here. Luis?
Sir.
My friend. What's different about this one from the example we did earlier? You want to give it a crack?
One is a value, and then the spam is going to call back to where you defined it as.
Okay, so the index 0 of spam, what kind of value is that?
What do you mean?
I'll give you some examples. Is it an integer? A float, a number, a string, a boolean? Let's take a look at it. We go up here. Here's where we're setting spam, right? We can see spam 0 is a cat. What is a cat?
It's
String, right?
yeah.
The string. Come on in. So cat is a string, right? So span 0 is a string that says cat. So when we look at this, we see hello and we see span. And span is a list, right? So we just went in that. Python has these things called lists. They can store more than one thing. Span is a list. We set it up here. We said this is a list of cat, bat, rat, and elephant. But when we come down here and we see span 0, we're not adding hello to a list. We're adding hello to the first element of that list, which is a string, right? So let's go back to our example, which didn't work, right? Here's our example, and it did not work. And it didn't work because we're trying to add one element, right, to a list. But their example did work. And the reason that that did work is because we're not adding a list anywhere in that. We're adding a string hello to another string cat. So that type of the 0 element, right, the 0 index of span is a string. That string is cat. We're adding hello and cat, not hello in a list. I just want to be very clear about that. So when we come down here and we look at something, right, let's say A equals 1, 2, 3. Let's A equals, I hope everyone can read that. A equals 1, 2, 3, right? We have A. We're showing it as a list 1, 2, 3. If I take A of 0, right, that's not 1, 2, 3. That's the first element in that list. What's the first element in that list?
1.
1, right? 1 isn't a list. 1 is a number. You can add things to 1. So I can say A0 plus 5 and we get 6. But I can't say A plus 5. But I can say A plus a list with one element in it that's a 5. What do we get there? Right? I said you can take two lists, you can add them together, and you extend one list with the other. You make it longer. That makes sense to Python. List plus list, longer list, more stuff in it. Right? You can also take a number and add it to another number. And I'm showing you both of those here so we can see what they look like, one next to the other. Does that make sense to everyone? When we access one element of a list, it functions like that individual element. But you can treat the list as a whole and do special cool things with it. All right. Susan.
Here's the question. On the example you just had, like the A0
Let's look at it.
plus 5.
Okay.
You already said this. Why does that not create a list?
Aha. And I bet you this is maybe slightly confusing because you come from R, right? And in R, these
There is a definite, unique way to make a list in R, and it is beautiful because it is concise and not vague at all.
So R doesn't really have a concept of anything being single, right? R only has these things like
No,
lists.
you can declare single like an integer type variable. It doesn't have to be in a list. It defaults to lists a lot of times, especially if you're working with tidyverse, which I mixed again.
You're going to have to show this off. So let me explain to you the answer for this in Python. What we have here, right? Am I screwing something up? Okay. We've got a lot of people doing media now. We have live streamers and video recorders. So if I ask them what's going on, it's just because I want to make sure that everyone has access and has all of what they need to do their work. Okay. So we have two notions here, right? A list is 0 or more things. We have a method of accessing the things inside of that list. And when we access the things inside of those lists, we can treat them like they are their individual member, outside of the list entirely. So we can treat the list as if it had all of that crap in it, right? Like you can say, I can say I have a handful of, writing utensils. Right? And I can do specific things with a handful of writing utensils, like throw them against the wall, right? But if I'm going to write a document, I just want one of them. And when I have one of them, I can do more useful things with it, or different types of things with it.
Got it.
So with Python, we can treat the container as a whole and do things with it, move it, extend it, add things to the container, remove things from the container. But we can always access those individual elements inside of it and treat them like those individual elements they are. Okay, I hope that kind of, connecting the points everyone needs for lists. Does anyone have any questions about this?
You lost me on that very last example. I don't know what the 5 in the brackets is.
The 5 in the brackets, it's a good question. The 5 in the brackets is a list, but it only has one thing in it. Right? So a list has 0 or more things inside of it. If I do this, that's a list with nothing. If I do this, it's a list with one integer, 5. If I do this, it's a list with 2 integers, 5 and 6. So I said we can add lists together, right, to extend that. 5, 6, 7, 8, 5, 6, 7, 8. But you can also take a list of 5 and 6 and extend it by 1. Right? So in the example here, when I said A plus 5, A is a list, and I know one thing I can do with the list is add another list to it, and that's exactly what I'm doing. What I'm adding is a list with only one element. Just throws it in. Okay. Does that clarify it? Very cool. Anyone else? Awesome. Okay. So we have these containers, and we know we can throw things in them. Right? We can throw different types of things in them. And we can also access one individual element from inside of them. Right? So we move on, and we look down here, and we say hello cat, because we have hello and spam 0, which is cat. Right? And then that's going to create the string hello cat. And that's all that they're showing here. Now, this is also, we go down, and we say, okay, we can access each individual member of that list, right? Well, can we access those individual members at different times? Yes, you can. So here we have the string the, and we're adding to it what? Spam 1. What is spam 1? We come up here to spam, and what's spam 1? Bat. So we have the bat plus ate the. Now what is the bat eating?
Cat.
It's eating a cat. The bat ate the cat. It's a great example. Wait till you see the one that I whipped up. Okay. So that's really all there is to that. Now we look here and we can see here that when we try to we access the different elements of the list with an index, right? So one of the questions you may have is, well, what if I try to access an element that doesn't exist, right? If you try to access an element that doesn't exist, Python errors out. It gives you this warning right here. It says, hey, idiot, you have a container, but you're trying to go into an area of that container that doesn't exist, right? That's pretty simple. You can think of it like, think of a container that has, I don't know, I have to think of a real world container that acts like a list. That's kind of complex. The point is, with Python, when you have a list of a certain size, if you try to access an element outside of that range, Python's going to throw an error. It's going to essentially say, you can't go there. So we have lists, right? And inside of these lists, we can access each individual element of that list with that position, that 0, 1, 2, 3, that index, right? What happens if we try to provide an index that is a float? By the way, I've never tried to access a list with an index of a float, so it's interesting to me that the book even takes the time to tell you. But it actually errors, right? And I don't know why anyone would ever try to access the 1.0 or 1.1 element of a list. It's really awkward, right? But yes, Python here is just simply telling you that if you have a list, right? Like let's come over here and let's say A equals 1, 2, 3. Now I'll call on Liz in the back. Liz, could you tell me if I have a list right here of A equals 1, 2, 3, what would my 2.5 element be? It doesn't make any sense, right? What's the second element in that list? So this is the first, right? The first element is 1. The second element would be 2, right? The second element is a 2. But you have nothing in between there. So Python errors. It just doesn't like floats, right? So you can just, it doesn't make sense to do it anyway, and Python doesn't like it. But that's all the book is talking about. Right? Okay. So we talked about this in the very first slide I did, right? I showed you how you could create more complex data structures with just simple lists, right? You come back here to the very first slide, and we started off with the slides. And we have this thing right here, and I said we can store all of this stuff in lists within lists, right? And that's exactly where the book is going right now. So we look and we see that the book has a list here, spam, and inside of that we have one list, which is cat and bat, and another list, which is 10, 20, 30, 40, 50. Those are two different lists inside of one list, right? And you can do that in Python. There's no problem with that whatsoever. So if we do that, and I say, okay, get me the very first thing in the list, spam, what do we get? Can someone tell me what it's returning right here? We have this thing. What is this thing?
The list that's in the 0th element.
That's right. It's a list that's in the 0th element. and it's a list in this case of strings, right? It doesn't have to just be strings, but that's what we have in it. So now when we access this, we say, what are we saying? We're saying exactly what you said, Zach. Zach, say what you said again.
It's the element in the zeroth, right? The zeroth element, but that would be the first element, or sorry, the second element of the zeroth element. I'm mixing up the two systems of saying it.
That's fine.
Sorry,
yeah.
the first and the second element, or the first element, sorry, the second element of the first element, whatever.
Let me help clarify. You did the first one so elegantly. It's like ice skating. It does get to be a little tongue twister though, and you're going to have to get used to seeing it, right? So what we have here is we're saying get me the first element of spam, which is in fact a list, and then we're saying out of that list, I want the second element of that list. So here's the first element of spam, and now I want the second element of that list, which is back. And that's what we get back. We get back. Okay? So when we have lists inside of lists, we just keep adding indexes. We say I want the first list and I want the second element in that list. And that's how we do it. That's what we're introducing now. We're introducing that syntax to do that. Okay.
So on the example after that, Evan, where it has the spam with 1 and the 4, can we get the first elements of the first element of the second list? Because like it says spam 1, so that's the second
Okay.
list.
Focus on this one, Marcel. If I see spam 1, what am I going to get? Go up here. This is spam, right?
Mm-hmm.
What is spam 1 going to return?
The first list.
Tell me what it's going to return. You're good? Tell me what it's going to return.
Cat. Let me know. That's the first. So for the first list. Oh, spam 1. Oh, second list.
There you go. Right? Because there's zero stuff. They start with 0, so it's going to return the second list. So when you say the second list, for everyone watching, tell me what the second list is.
10, 20, 30, 40, 50.
Okay. Now what we're asking for is out of that 10,
element.
which is
element.
0 based. You're close, man. This is called an off by 1 error. We're going to go over this in a second.
Oh yeah. 1, 2, 3. Oh, 50.
Okay.
0, 1, 2, 3, 4.
0, 1, 2, 3, 4. That's exactly right. Okay, so we just got introduced to something new there, right? We got introduced by what they call the off by 1 error, and that's important to go over. It's always important to remember that people start counting on a finger or a thumb. You have 5 of them on a hand. Computers start counting at 0. We don't tend to think of that because there isn't a 0th finger, technically. But imaginarily, there kind of is, right? So when you're talking to a computer, imagine the thumb on the other side of your pinky going up first, and you'll always be good. That's how I do it. Yes?
Would it be less confusing in English to refer to the 0th element and then the first element?
It would be less confusing to do that, but no one does that. You normally say it's the first element of the list, right? And you index it with 0.
So
Robert?
I normally find it less confusing rather than trying to like translate the terms in my mind and saying, oh, I see a 1, so I'm going to say the second element. I just say that's element 1, as if there's a label over it. So there's element 0, element 1, element 2.
Okay, I actually like that. I've never heard anyone do that in my life, but let's do that. Because that sounds like that would be less confusing. To answer your question, I agree with that. What you're saying would be less confusing too, but that's just not the way it is. You almost always, maybe Ed's heard this differently, I don't know. I've never heard of anyone referring to index 0 as anything but the first element in the array.
So a couple of times in past classes, and maybe even in this class, we've talked about the difference between indexes and position. And basically we make this artificial distinction where one is an offset and then the other one is, say, a natural counting number. Because of efficiencies, computers use offsets to find elements in lists. When you create things with sizes, though, they'll actually use a counted number. So a list with 5 elements has the offsets 0 through 4.
Have at it. All different ways. I like my imaginary non-existent thumb. I don't know if it's going to work for anyone here. Kenya?
Is there a way to print in this notation an element of list at the same time? Like if I want to print cat next to 10, can I do it?
Cat next to 10, yes. You can do what they call zipping the list. And we'll get to that in a minute. You know, I don't know that we're going to get to that in this lesson. This may be something we have to go over, you know, outside of the class. But yes, in Python you would either do that with zipping or with what they call parallel list comprehensions, if you want to look it up. Both of those would work.
Could you write, say, spam, and then have the list 1 and 4, and then just have the plus sign, and do like maybe.
Let me ask this question, Kenya. Were you asking for just one case, or did you just want to show cat and 10, or do you want to show cat 10, bat 20, so on and so forth?
Yeah, like mapping.
Yeah, that's what I was trying to address. If you just want to show cat and 10, you can do it very simple. You would just say spam 0, 0, spam 1, 0. Then you'd have cat and 10. But if you want to go through both of them, like I think she was asking, that becomes a little more complex. We're not going to go over that just yet, but hopefully sooner than later. Okay, so negative indexes, right? Ed mentioned offsets, right? Offsets are from the beginning, but Python will actually map negative offsets to the end. So that works totally fine in Python. If you want the last element of a list, right? If the first element is 0, subtract 1, you get negative 1. That's the last element. It's actually a very clean way of doing it. And other languages, some of them have adopted this as well, or have this as well. So you can say, I want elephant by doing spam negative 1. I want bat by doing spam negative 3. This is negative 1, negative 2, negative 3. All right. So we have now the spam negative 1 is afraid of, we just went through that. We just had baby shrimps. Okay, getting sublists with slices. So now we have this container, right? And this container has a bunch of stuff in it. Well, all of that stuff is ordered. We talked about that. That's one of the features of a list, is that things are in a specific order. Well, what if you want to get a group of things out of a list? We know how to get one thing out of a list. We get one thing out of a list with an index. If we want to get a group of things out of a list, can we do it? The answer is yes. When we get one thing out of a list, right, we do it with an index. When we want to get multiple things out of a list, we do it with this slice notation right here, right? So the slice notation, 1 through 4, is a list with a slice, 2 integers, right? So let's come down here, and I'm going to show you, geez, that is. If I take here and I say A equals range 10, A, no, that's not what I want. Let's just do it here.
Eval range 10?
What's up?
Could you do eval range 10?
I'm not going to get things more complex than you need. Okay. So I have A, 0 through 9. That's my thing. If I wanted to get a range of things out of it, I could. I could get, for instance, all of the things from 0 through 2 by doing something like this. 0, right? 1, 2. Now if I look at this, that's actually exclusive. It would be, that's another off by 1 error. 0 through 3, right? So you start off with the 0. That's going to be the very first element I grab. And then I'm going to go up 2, but not including that last element. Right? So 3 is going to be 0, 1, 2, 3. This is the third element. Right? I kept them the same as the index. When I say I want to get 0 to 3, that 2, 3 doesn't include the last piece. Right? So we would say it's exclusive of that last element. Okay. So let's also look at this. When I do this slice, right, and I'm doing the slice, what is it returning here? Anyone want to take a crack at this?
List.
It's returning a list, right? So if I want to get one element from a list, I get a number back. But if I want to get multiple elements from a list, I get another list back. That's how it gives them to me. So you can treat this list you get back, right, in the same way you could treat the list it comes from. Because all lists can be treated the same fashion. So if I want to do something like print A, right, I'm going to print out that list. If I want to do something like print A 0 through 6, there we go. If I want to do something like that, I'm just going to print a subset of it. So the point here is that we have a print function, and that print function is taking a list. And it knows what to do with the big list the container comes from. Because the slice is just a smaller segment, it's going to treat it the same way. All right. So we have here cat, bat, rat, elephant, and I say that I want to get all of the elements from 0, the 0th element, up to, but not including the 4th element. That's what I do here. 0, 1, 2, 3, up to, but not including the 4th. Cat, bat, rat, elephant. Boom. If I do 0, spam 1 to 3, I'm going to start off with the first element, bat, and then we're going to go up to, but not including the 3rd element, right? So 0, 1, 2, 3, but not including the 3rd element, rat. So now we're going to get bat and rat. Okay. So here's spam, and I'm going to do the same thing. Spam 0 to -1. We're going to start off with the 0th element, which is cat, and we're going to go up to, but not including the last element, which is -1. 0, 1, 2, we're done. Because we're going to go up to, but not include that last element. Okay. And this is prime. You will find more languages than not. They exclude that last element from the range that they're in. It's normally you include the first element, and you go up to and exclude the last element. Okay. So we have here more stuff. Now, if we don't put anything here, we've seen the syntax before, where we have 0 to 2. What if we put nothing there? What does it do? Well, then it just assumes that you start off at 0, right? So cat, 0, 1, up to, but not including rat, you get cat and bat. Now, if you start off with a 1 and you don't tell it where to end, what happens? It goes to the end of the string, goes to the end of the list, right? So we start off here and we say we want to get the first element, 0, 1, and just keep going. That's what the syntax means. Same thing here, except now we don't have a starting element or an ending element. So what do? We get a copy of the entire list, right? We say start at the 0th element and just keep going until the end. You get all of it, right? So now we have getting a list length with length, right? I always found this kind of confusing. And I'll tell you why. There are a lot of things you can do with an array, and you'll find a different syntax for them later, right? You use what they call the method syntax. But in Python, length, to find the length of the array, you use len. And now here's the catch. When you say the length of the array, right, we have an array here which has 3 elements in it. Length is returning 3. To get back to why we don't just change the way we say everything, I think it's functions like this and languages like this that make that all the more complex, right? Because we have that array isn't size 2. We don't just magically adopt computer speed, right? Length is actually human speed. So length being human speed, it's going to start with the 0th element being number 1. So when you say, what is the size of the array, you're going to be talking about 1-based length, right? Okay. I hope that makes sense to everyone. The only thing that I want to emphasize here right now is that computers start at 0, humans start at 1. There are functions, though, within the way we address an array, and when we say something like length, we're not starting at 0, right? If the array has a length of 0, it looks like this. If we do something like this, there we go. If I do A equals this, and then I say length of A, that gives me back 0, because there's no elements inside of that array. If I do this, and I type it right, I get back 1, right? Because there's 1 element in that array. So I just want to be sure we're clear about, when things are 0-based and when things are 1-based. Okay. And we have pizza here. Let's do this one more. Okay. So we have this spam, and we have cat, bat, rat, elephant, right? And now what we're doing is we're introducing a new thing where we're actually setting from an index. It's the only thing new. So if we say spam the second element with the index of 1, we're going to set that to argvar. What do we get? you get cat, aardvark, rat, elephant. And that's what they're showing here. We can also set things in different elements of that array with other elements of that array, right? So we can use that index notation on either side of the equal sign. We can set things in the container with it, and we can retrieve things from the container with it. And here's the unity of that syntax. Here's where we see both of them. Now we're saying set spam2 with spam1. Spam 0, 1, 2, rat with spam1, cat. Right? So now rat becomes cat, and 0, 1, 2.
Yeah, that's
Rat
Bart
becomes
replaces that.
There we okay, because this is sequential, so we've already replaced. Okay, so that example could be better written. So we have in the first one we set spam1 to aardvark, so bad is now aardvark. In the second one we set rat to aardvark, right? So you look at the second one when it's returning. Now rat becomes aardvark. You get cat, aardvark, aardvark, elephant. Now in the last one, right, we're taking -1 and we're setting it to 1, 2, 3, 4, 5. Where's your name in the back row?
Chris.
Chris, what's going to happen if we set -1, the -1th element to 1, 2, 3, 4, 5?
The last element is going to be 1, 2, 3, 4, 5.
That's exactly right. So you can set things also with that negative syntax, and we're totally good there. Okay, and let's break for pizza. Is that cool? 6:49, or you guys want to wait another 15? Let's break for pizza. I don't ever want to hold people here when we have pizza. It's a losing battle. So we have some examples here. I wanted to go through these. These are kind of fun and cool. Cool. Someone's happy. So I have here a list of countries, right? And someone make an observation about this list. In what order is this list? Is it in alphabetical order? No. Okay. So it's not in alphabetical order. So we're going to come down here and we look at this list, right? And I created this little function called defprint. Now we already went over functions, and this is a pretty baby function, so we should kind of already understand what this function does. This function looks at, it essentially takes a list, and for every element in that list, it sets I to each different element. And then we print it out, right? In Python, printing out, you get a new line. So if I come down here and I say print list, what are we going to get? We'll delete that, I'll save it, I'm going to go run, I'm going to say run, I'm going to say countries, and we're going to get our list right here. It gets them all printed out. Now that list is not sorted, so how can we sort that list, right? Well, there's a function in Python, it's called sorted, and essentially you give that function a list and it returns to you a new list that is sorted. And we're going to go through some more of this in a minute, right? But I'm just going to take that very same thing and we're going to run it, and now we have that list sorted. Right? So you have a list and it has a bunch of strings inside of it. And they're in no specific order. Let's look at it. See how United States is up at the top? I'm always amused that we still get away with this, but if you ever go to a form and it asks you to select your country, you ever notice what comes before A? Yes. What idiot did that, you know? Like, the technology is there, even if they want to make it jump to the United States to do so without putting U above A, but so many people do it. It's great.
It's based on country though, because if you fill out a form in the UK, it's the UK is first.
Maybe. If the country is not American.
Yeah, if the country is not America, then there's going to be the home country where it was developed.
They're not eating the freedom fries. Okay, so yeah, that's how we rock over here in Trump land place. So what we have is we can sort that list easy. That's all I'm trying to show you here. So I'm going to come down here to this next list, and this one here, you'll notice that I've already sorted it, right? So this is a list and it's sorted. And I called the list countries. Anything stick out in this list? How about the fact that not all of them are countries? The Caribbean is a country, right?
How about ones that have spaces?
Yeah, there's a lot of different things that could stick out, but the one that I really wanted here is that the Caribbean is not a country. Unless you are 110% American. Okay, so how do we fix that, right? Well, in Python, we have this thing that has an index, right? And we can access any individual element with that index. So you look at the array, and every element in the array has an index. That's the offset from the array that Ed talked about earlier. Well, we can delete with that offset. So if I say delete countries 1, and I print it out again, what am I going to get? Well, now my list of countries no longer has inside of it that Caribbean, right? So if I run this one, and this does through, because the first time you got to select to do this thing, I think. Okay, there we go. Now here's my list, and you'll notice there's no Caribbean. Okay, so these are all things that we've kind of went over before. I just showed you del, I just showed you sorted. We haven't hit them yet, but it's nothing much, nothing too hard to swallow here. So now we're going to go over here to my third example. And in my third example, we have all those same countries that we just saw, except Caribbean, right? And what I want to do is I want to go through them, and we're going to start calling out some of these indexes right here, right? So we're going to test everyone's ability to see indexes. I'm going to start over here with Jessica, and we're going to go right down the middle row, okay? So you're going to name the first one, which is this one right here, which is -1. And then we're going to go through, and Zach, you're going to do the second one. And then you're going to do the third one, so on and so forth. Now, you'll notice here this is a slice, so you have a tricky one. Yeah. We're going to get there. Okay. But here's the thing. After you name it out, if I tell you you're right, I want you to remember it and hold it, right? So if it takes you a second to figure it out the first time, remember it. So if we do it again, and I ask you, you can name it out the second time. Okay? Let's play my game. Jessica?
-1, United States.
United States. Okay, Zach?
Canada.
Canada? Okay.
I'm actually confusing this. There's only one of this.
I'll help you out, my friend. What's your name?
Andres.
Andres. Okay. So what do we have here? We have a 6 and an 8. So this makes it a slice, which means we're going to get more than one thing back. Which means you drew the short straw. You got the difficult one. Okay. So what we're going to do is we're going to start on the 6th element, right? So count down. We got 0, 1, 2, 3, 4, 5, 6.
Okay. So Mexico, Panama.
And then we're going to go
Panama because it is Cruz the 8th one.
That's right. So what do we got? Mexico?
Mexico and Panama.
Panama.
What am I, 4? Haiti?
Haiti. Very cool. All right, don't forget Haiti. Remember, this is a game. Jonathan, my friend, you're number 5.
You got Jamaica.
You got Jamaica. Marcel. Peru. Dan.
What's the question?
Okay, so we just did Peru. You're -3.
-3. Okay, I'm sorry. Okay, I see. Never mind. 1, 2, Peru.
Wait. Okay, so we got 5 here. We have 1, 2, 3, 4, 5. Haiti. Someone didn't do this right.
So you told him -3, but -2 was the next one.
Yeah.
Oh, okay.
We already done -3.
So we already did -3. Okay,
Yeah.
so -3 is Peru. Okay, so then we're moving on. Wait, you got -3, Jonathan. Who got -3?
I did.
You got -3. So
Okay,
Dan,
okay.
you're -2. I'm sorry.
Okay. -2, Republic, should be Dominican Republic, right?
But it's Republic Dominican, so that's what you
Okay,
got to
all right.
remember.
Okay, all right.
All right. Next up. So you're 1, and we're gonna go for the top. What's 1?
So that'll be Cuba.
Okay, Cuba. And then we got next. Now what's next? What's after Cuba? You have a string, so you got the easy one. Caribbean. That's it. Okay, and we're gonna go up here to the back. Robert, you got 3, right? So we're gonna come up here back to the list. What's number 3?
Greenland.
Greenland. Okay, Liz, we got one more after 3. You're 2. So Liz, what's number 2?
El Salvador.
Okay. And right after that, right after El Salvador, we have what? We have a string. See the string?
I'm trying to see if there's a camera right
Oh, you can't.
2?
That's it. Okay. So now we're going to go through, and everyone's going to call out what they remember. Jessica.
United States.
Canada.
Mexico.
Haiti.
Jamaica.
Republic Dominican.
Cuba.
El Salvador.
2. There we go. Okay. Do you know what that was from?
The Animaniacs?
Animaniacs.
Maniacs. That's actually one of the best songs known to man. I don't know if, see, like, we had speakers up here, and then I think we just showed them something. But yeah, if you don't know this song,
You can sing along
this is
yourself,
the
right?
coolest song ever in the world. Yeah. So yeah, we just reordered the list, and we took it, and we sorted it, and then we sung the nation song. So yeah. Anyway. Yeah, we did. So they do say Caribbean in the song. They say.
Actually said.
What's up?
They actually say this.
Yeah, the United States, Canada, Mexico, Panama, Haiti, Jamaica, Peru, Republic Dominican, Cuba, Caribbean, Greenland, El Salvador, too. Yes. I can do the whole thing.
The states and the capitals one?
I can, yes, I can. Baton Rouge, Louisiana, Indianapolis, Indiana, and Columbus is the capital of Ohio. Okay. List relations and list replication. And I can also do the elements, which is the Tom Lear song where it goes to the whole periodic table. That one is cool. Okay, so we said we can have two lists here and we can add them together, right? And when we add them together, we concatenate them. So we have 1, 2, 3, ABC. Nothing special there. We have X, Y, and Z, and Robert threw this one up at the beginning. He said, oh, well, what if using multiplication instead of an addition? Right, what Robert was actually saying by that is, hey, you know, multiplication is repetition for lists, right? So if we have a string and we multiply it by number, like I say, apples times 3, what do I get? Apples times 3. Kenya, you got to speak louder because you're right all the time. You're quiet too frequently.
Apples, apples, apples.
That's it. It's so easy. Apples, apples, apples. Okay. We get apples, 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 right? And if we take this XYZ times 3, we get XYZ, XYZ, XYZ. Nothing special there. Spam, 1, 2, 3. Spam equals spam plus ABC. What was your name? Right next to Kenya. I totally forgot it. I'm gonna call on you. You're way too quiet.
Feza.
Feza?
Uh-huh.
Okay, Feza, my friend. What is this gonna give me? Spam equals spam plus ABC.
Whatever the spam is at that plus ABC.
Okay, so spam is not whatever. It's
Oh
what?
yeah, 1, 2, 3 ABC.
1, 2, 3 plus ABC. That's all going to be a list, right?
Yeah.
And here's the catch. We're setting it equal, right? So what does that mean? What's going to happen here?
It changes whatever spam is to the new
Ah, precisely. 100%. Back row is right more than the front row. We got to fix this front row. Okay. So spam equals 1, 2, 3 ABC. Removing values from lists with the delete statement. Now we already saw this in my cute little example. We removed Caribbean and then we had to add it back, right? Because it's not technically a country, but it's in the song. So we got to sing it. So we have here spam equals cat, bat, and elephant. And what we're going to do is we're going to delete spam 2. Now we already said the second index is not the second element, right? It's the third element. So 0, 1, 2. We're deleting elephant. Right, so then spam equals cat and bat. Bada boom. Working with lists. Okay. So we gotta move a little quicker than this. Okay. We have here enter the name of cat 1, and then we say cat name 1 equals input. So we're gonna store cat name 1. Then we're gonna get the name of the second cat, the name of the third cat, the name of the fourth cat, the name of the fifth cat, yada yada yada. And then we're gonna say the names of the cat are all of these things, right? They're showing you that's a bad idea. Here's a better way of doing it. We say cat names equals an empty list, and then we say while true. And what does while true do?
Something like this.
That's actually okay.
Hey,
What's your name in the red shirt?
It's meant
Veronica. And what was your name? Francisco. Veronica Francisco. Okay. Veronica, what does while true do? It enters the loop, but when we say it enters the loop, is it how many times is it going to loop? Okay, and if it goes on and on and on, does anyone here know what we call that kind of loop?
Infinite?
An infinite loop, right? So if it goes on and on and on, we just say infinite. It's an infinite loop. That's exactly right there. Okay, Francisco, my friend, what's happening here? Tell me what is this loop that's going on and on and on? What is it doing?
It's looping for that free statement until literally blank.
So we're printing out here, enter the name of the cat, right? And then we're printing out the length of the cat names, right? +1, or enter nothing to stop, right? So we're saying here, enter a name of a cat, and then we're going to print out the length of that cat, +1, right? Because that's what, remember the off by 1 thing. Or enter nothing to stop. We say name equals input. If name equals an empty string, we're going to break. So if we give it nothing, we break. And that's exactly what it says here. Or enter nothing to stop. So nothing is this guy right here. that means we didn't get any input. That's nothing. So if we get that, great. Otherwise, what we're going to do is we're going to say cat names equals cat names plus name. List concatenation, right? So we talked about this earlier. You can't add 5 to a list of 1, 2, and 3. You can add a list of 5 to a list of 1, 2, and 3. You remember that? So what we're doing here is we're taking all the cat names and we're adding a new name to that list of cat names, right? And then what we're saying when we're done with this loop, when we finally enter nothing, we're printing out the names of those cats. So we have this thing here. We're saying, give me a name. And we set the name equal to input. If the name is blank, we're done with the loop. If the name isn't blank, what we're doing is we're adding it onto a list of cat names. And then when you finally give it nothing, we break out of the loop and we print out all of those names. So let's take this whole thing right here and let's see if I can copy and paste. And I told you copying and pasting is not my strong point. That didn't do what I expected.
Sometimes there's a line break in there.
Where's the other line?
It's after the print statement. It says plus.
Here?
No, up 4 lines there.
You think that's throwing it off?
Well, that is the indentation.
While this, no, it takes that. It breaks here. There we go. Okay. So here, enter the name of cat 1. Evan, Rico, and Mary. Great names for cats. Then we hit enter, and we have nothing else, right? So we're done. So we entered 3 names. It says, enter the name of the cat, I give it Evan, and then it's going to add it to cat names. Then what it's going to do is it's going to say the name is not blank, so it's just going to repeat because it's an infinite loop. Enter the name of the cat, I give it another name, it loops. I give it another name, it loops. But every time, it's adding that name to the list of cat names. Now what I want to do is I can run this command here, and we can print out all of the cat names. So if I take it and I paste that, if it wants to be friendly, this is why we don't copy paste. It's a lesson I just can't learn enough. File, new scratch file. Paste without formatting. That worked? There we go. Run. Run. On scratch. Okay. Enter the name of cat 1, Evan. Mary, Ringo. And we're done. And then it prints out the names of your 3 cats, Evan, Mary, and Ringo. Right? Okay. I want to show you all how it executes and what it's doing, right? So every time when you run it, if you don't get an empty string, we add that name to a list of cat names, and then we continue. And when you finally hit the empty string, we break and we print everything out. Okay, so we come back up here. This is how it used to look. This is how we would have had to write it before we knew how to do a list. But now that we know how to do a list, we can write code. And notice here, even without the list one, we're only accepting names of 6 cats. With the list one, we can run this infinitely. We can keep adding cat names to it. Okay, and then they're showing you some examples of wording. Okay, so we've seen this now twice. We want to loop over a list, right? We talked about how we can pass these containers around and do different things, and then we can sort them, right? We can do different things with the container itself. But if we want to go through that container and start to actually examine those elements, we can do that with this. For I in, and then the list, right? So this is cool because this allows us to actually take a look at those each individual elements and figure out, write code that does stuff. So we have for I in 0, 1, 2, 3, print I. This is going to print out all of the numbers between 0 and 3. So we can take this and run that, and we get 0, 1, 2, 3. So we can see the syntax here. That's what in does in this loop. It's going to go through each different element of this array, and it's going to set I to that value, the list rather. Okay, so we look here, and we have a supplies, and we're creating another container, pens, staplers, flamethrowers, and binders, and we say for I in range, the length of supplies, right? So now notice how we could do for I in, and then we could give it supplies, And if we did that, if I said 4i in supplies, I would get pens, staplers, flamethrowers, binders. But the length of supplies is 4, right? So if I do 4i in, and then I say range, I'm going to get a range of everything from 0 up to, but not including, 4. So if you look here, when you run that code, you're going to get index 0 in supplies is pens, index 1 in supplies is staplers, 2 is flamethrowers, and 3 is binders. You can iterate over the container, and you can get each individual element out of that container. Or you can use the indexes for each individual element and use those to access the elements inside of it. Does that make sense to everyone? Okay. Not ask a question. So this thing that we had earlier, inside of a loop, right? That does something totally different than in outside of a loop. And it can be confusing. In outside of a loop is going to test whether or not that list contains that element, right? So when I say howdy in, hello, hi, howdy, heyas, this is actually an operator, right? And this operator is saying, does this thing on the left, howdy, exist on the thing on the right? And you can see all of these different strings. If it does, and it does, it's right here, it's going to come back and say true. Right? So we can see howdy's on the left, howdy's on the right, we get true. When we say here spam equals hello, hi, howdy, heyas, and then we say cat in spam, it's going to say is cat in this element, in this list. Right? And of course it's not. So it can't find it. Howdy not in spam. So remember, what does not do? Francisco, what does not do?
Checks it's not on that one.
No, what does not do? Ignore everything you learned today. What does not do? If I say not true, what's the answer? If I say not false, what's the answer? True, right? That's what not does. That's all not does. So we have this thing here, howdy in spam, right? Howdy in spam. Look at this list right here. You see howdy inside of it? So then it's going to return true, right? But we have a not here, and then not true is, that's what we get is false. So not negates, right? It's just saying negate whatever I get back. So you have this containment thing in, it's telling you whether or not the left is, the right thing contains the left thing, right? Does in spam contain cat, right? If it does, it's going to return true. Not is just going to do the opposite. Okay. So my pets, Zophie, Poka, and Fattail. We say print, enter pet name, then we try to get something from the user. We say give me something, right? If name is not in pets, print I do not have a cat named name. Else print blank is my pet, right? So this is going to say here, give me something, and then see if it's not in this list up here, Zophie, Poka, and Fattail. If it's not in that list, print out this thing. Otherwise, print out it's my pet. Right? So it's just showing you how you can use that in piece. Multiple assignment trick. Cat equals fat, orange, and loud. So we have another container here. This is another thing we can do with a container. Size equals cat 0. Cat 0 is fat, right? So we set size equals to fat. Color equals 1, orange. Loud is this Trump or cat? Okay, so disposition equals cat 2, right? Which is loud. So we have a cat that is fat, orange, and loud. And then what we're doing is we're accessing each different element of that and setting it to a different variable. You could type that line of code like this. Cat equals fat, orange, and loud, right? So that's going to set the cat to everything. Now what they're showing you is this new syntax we have here. This new syntax is called, in computer speak, parallel assignment. So we're going through this list, fat, orange, and loud, and we're setting the first to size, the second to color, the third to disposition. Does that make sense to everyone? Remember, the order of a list matters, so you can assign one element from a list, but you can also assign multiple elements from a list. So here we have 3 elements on the left-hand side, size, color, and disposition. and we have a list with 3 elements on the right-hand side. And we're essentially saying we want to set all of the things on the left to all of the things on the right based on their position. You guys kind of see what we're doing there?
Would it still be the same thing if you change size and color? Would it generate something different?
If you change size and color, then what's going to actually happen is, like, if you had color here, then the color would be fat and the size would be orange. Yeah.
Why doesn't it have to be a list on the left-hand side? The size, color, distribution.
That's just the syntax of Python.
Okay.
Right? So that's really just in some languages it is. In JavaScript it does look like a list. So yeah.
Could you have, like, say, 2 cats represented there, and then say size, color, disposition equals cat, which is where cat would have 6 elements in it?
Could you say that one more time? I'm sorry.
Let's, like right now, you can see this just, so size equals fat. So a single cat has those 3 attributes.
Right.
Could you put, inside that cat list, could you put the attributes for 2 cats, which would be 6 elements, and then say size, color, disposition equals that list that has 6 elements in it?
So let's go through it. Let's share. So let's create a list, right? And we're going to say here, let's use copy and paste. We're going to copy this guy right here. So we want 6 attributes rather than 3, right?
I'm saying, let's say put in information for 2 cats.
Okay, so the second cat will say skinny.
So it'd be plus when
Yeah, so skinny, blue, quiet, right? So we have 2 cats now.
Wouldn't it be plus? I was thinking you would add those 2 lists together, so have one. I wonder if you could have one list with 6 elements in it,
like
which
this?
represented the data for 2 cats.
Okay, so we have this one which represents the data for 2 cats, right? Is that what you're talking about? But you want one list rather than a list of
right.
lists.
Get rid of the.
So like that.
And then can you go and then assign the characteristics?
Yeah, so you could do
Same
something.
thing.
You could do something like this, right? You could do size, or you would do size 1.
Okay, you have to, all right. I wonder if you could generalize it and then refer to like cat 1 and cat 2 something. I mean, I see how you.
Yeah. We'll talk about more advanced methods of looping over, which will make that easier later.
Like a dictionary.
Yeah. There's a lot of easier methods of doing that. One method would be like anytime you have like duplicate cats inside of one array, right, one list, a real question would be, why do you not have 2 different things to represent the 2 different cats? Why are they ever together in one thing, right? So the first thing is, how do I pry those 2 things apart? And you can do that. Like if you take this right here, one of the things you could do is, if the cat really does equal all that, you could say cat 04, right, 03.
Yeah, right, yeah.
And then the next one would be cat 36, or 37, rather. Right? So you can do that, and you can iterate over them and actually pull apart each different cat in your list and work with it. Okay. So the number of variables and the length of the list must be exactly equal, or Python will give you a value error, right? So this gets back down to the point. If you have lists of different sizes, they have to be equal, right? Or you're going to get this value error from it. So we see here cat equals fat, orange, and loud, but we have size, color, disposition, name equals cat. There is no name, right? So we have 3 attributes here for a cat, and we're trying to assign an additional name. So Python goes, what do I put name to? There is no right answer to that. So it throws an error. It says the lists are out of unequal size. AB equals Alice and Bob. And then here's what we're doing is we're saying AB equals BA. Now we're switching them, right? Print A, Bob, print B, Alice. So we set originally A and B to the first and second elements of this, Alice and Bob. Then we set A and B again to that same thing reversed, right? So we just assign the opposite, the other, we're switching the elements. Augmented assignment operator. We have spam equals 42. Spam equals spam plus 1. Now spam equals what?
43.
43. Spam equals 43. As a shorthand, you can use the augmented assignment operator, plus equals, to do the same thing. Spam equals 42, spam plus equals 1, spam equals 43. Okay. And I think we went through some of this stuff earlier. the augmented assignment operators. I think Ed may have actually covered these in that lecture, that as well. But there's quite a few of them. They're just shorthands. You can just think of them like that for now. Okay. Spam equals hello, hi, howdy, heyas. Spam index hello, right? Now what we're doing is we can use this thing index and we can find out what the index is of that element we're looking for, right? So if we want to find out, let's say we have spam equals hello, hi, howdy, heyas. If we want to find out if hello is in that list, we could do what? Ursula? Okay, does anyone remember what it was? It was a 2-letter word.
In.
In, right? In is going to test whether or not that thing on the right contains the thing on the left. Index is not just going to tell you if it contains it, it's going to tell you where it is, right? So if you want to know which one of those things is there, you can use index, and it's going to tell you where it's at. So if I say spam index hello, I get the 0th element. Spam index heyas, I get the 3rd element. And if nothing exists, right? Spam index howdy, 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 it's actually going to give you an error. Howdy, howdy, howdy is not in the list. Whereas in would return what? If it's not in the list, what does in return?
False.
False, right? So in returns a Boolean, and this one actually returns it keeps an error. When there are duplicates of the value in the list, the index of the first appearance is returned. This is very boring. If there's more than one element, you just get the first one. I think there's actually indexes or something like that for all of the indexes. Okay, adding values to the list with append and insert. Right, so we talked about how a list is positional. It's the first characteristic. If you want to add something out to the end of the list, we use append. If you come here from any other language, this is push. Right? So we say spam append moose. Now we have cat, dog, bat, moose. This is a Python. We're pushing moose, appending moose onto the end of the list. Right? Now it's interesting to note that it's not the only way to do it, right? Because you can use append, but what is this doing? If I do 1, 2, 3, and then I want to say 4, what does that do? It's append. If I do 1, 2, 3, except the right way, 1, 2, 3, and then I do dot append 4, what do I get? Well, no, that's because I did that wrong. 1, 2, 3, a dot append. 4, a. 1, 2, 3, 4. So there's one subtle difference here, and that is that a dot append modifies the list. Right? I want to be clear that that's the difference. So they're not exactly the same thing. You can use them in similar fashions. When I did 1, 2, 3 plus 4, I got a new list back with 1, 2, 3, 4. When I did 1, 2, 3 dot append 4, right, I was actually adding one element to this list, but you just couldn't see it because I didn't have a variable name on it. Then I had my oh shit moment, and I actually assigned 1, 2, 3 to A, and I said a dot append 4, and what it did is it actually mutated. It changed this list with the 1, 2, 3, added a 4th element on it, and now we can see it right here. Right? So when you do this plus thing, you actually get a whole new list back. When you do append, you modify the list. Okay.
Does Python not have pop?
No. Actually, I think it has pop. It doesn't have push. Right. So this is an important question. We had this come up. I think I hit on this the first class. I know I hit on this 1,000 times in the last whole series of classes we did. If you ever forget something in Python, what do you do?
Help.
Help. Right? So how would you find out if it had pop?
Help A.
Well, not help pop, because what if it does or doesn't exist, right? If it doesn't exist, if you want to look for all the things you can do to an array, you would do help, and then you would just give it an array, like A. Or you could give it an empty array, like that. Either one of those two things. Let's give it a shot. Let's look together. Help and an empty array. And now we see a help on list object, and I can go through here, and I can see all of these are the different things I can do with it, and then there it is, pop, right? So that's how we answer those questions. We don't even have to go online. We can just look at the help screen for the array. Right? Make really good friends with those utilities because they will save you lots of time. And you'll use them in every language. Okay, so spam, cat, dog, bat, spam.append moose. Now we have spam is mutated. It has moose. Spam equals cat, dog, chicken. Spam.insert right? Now we're seeing something new into the first element, right? The first, into the second element, right? The first index, chicken. Spam equals cat is the first element, chicken is the second element, dog is the third element, and brat. So where did chicken go? That's right. That's right. So if I would have done insert 0, it would have went to the front. But because I did insert 1, the second element is what I'm creating. Okay. Notice that the code is spam.append moose and spam.insert with the index chicken. Not spam equals spam.append moose and spam equals spam.insert. The point here is that you're changing the original copy, right? So we're going to come down here, and now we're looking at this. Eggs equals hello, eggs.append world, right? You cannot add to strings using .append. That's all they're showing you. You can only append and mutate things that are mutable, right? So not everything in Python is mutable. Lists are mutable. You can change a list. You can add things to it, remove things from it. Does anyone remember, by the way, we went through it very briefly, and I showed it to you when we were singing the song. How do we remove an element from a list? Yeah, that's right. And he gets it right all the time. She sits in the back and bounces. You're going to get them all right. DEL. So we remove a list with DEL. We insert to the beginning with 0. We can add to the end with append. All of those things change that list. Bacon equals 42. Bacon.insert 1 world. Right. We're now adding to the first index. We're adding world into the element after the first index. Okay.
They're gonna let you do it.
That's right. Yeah, because it's 42. I'm sorry. I'm totally losing track of what we're doing here. If you can't insert into a number, clearly, right? That's exactly right. So when we say bacon equals 42, 42 is a number. Insert is a method that expects it to work on a list, right? You can't add to a number at the end of a number. You can't add to the beginning of a number. You can only do those operations on a list, right? So you have to have a container to do those things. It's not a container. Removing values from lists with remove, right? So we have spam equals cat, bat, rat, elephant. Spam.remove bat. Now notice when we did del, we had to provide the index, right? When we do remove, we can just give it the value. So there's your difference there. So spam.remove bat goes to the list and it says, I have a bat. If I do, I'm going to remove it. If you try to delete a value that doesn't exist, you get an error. This is the same behavior you see with things like index that work the same way. Index looks for something in a list. .remove goes out and looks for that thing and additionally removes it. If the value appears multiple times in the list, only the first instance of the value is removed. This is the same way index works. If you have a list and it has lots of things in there and you call index on it, you say, give me the index of that thing, you only get the result of the first thing it finds. And with remove, you only remove the first thing it finds. So here we have cat, bat, rat, cat, hat, cat, and we remove cat, and only the first one's gone. The del statement is good to use when you know the index of the value you want to remove from the list. The remove method is good to use when you know the value you want to remove from the list. Okay. Sorting values in a list with the sort method. Spam equals 25, 3.1417, whatever. Spam sort, right? If you call .sort from the list, it modifies the list itself. So now spam is sorted, right? We can do lots of things to a list, including mutate it. You can change the order, right? But the order is always significant. So now we're changing the order, and things are reordered from lowest to highest. Spam equals ants, cats, dogs, badgers, elephants. Spam.sort. What is that going to do? Well, it's going to sort them in an order that we call, computer programmers call alphabetical. So in this case, it doesn't matter. We're going to get to that in a minute. Ants, cats, dogs, badgers, elephants. Spam.sort. It's in alphabetical order. Ants, badgers, cats, dogs, elephants. This is the same thing I used when I cleaned up that list of countries when we were all singing. Spam.sort reverse equals true. This is an argument you can provide to sort, and it essentially does the opposite. sorts them in the opposite order, right? And of course, if you try to give it things that don't make sense, like 1, 2, 3, 4, Alice, Bob, it doesn't know where to put Alice and Bob when you have numbers. You can't compare a number and a letter, right? So it's going to give you an error. And it's the same type of error that you would get if you tried to add a number to a letter. So if I come over here, right, and I say 5 plus A, I get an error. If I try to say 5 is greater than A, I get the same type of error, right? That's what sort is doing internally. Sort is looking and it's saying, can I compare these two things? And you can't, at any level, compare numbers and letters. So that error happens and it bubbles up and sort says we have a problem.
Would you still get an error if you made the integers into strings?
No, you would not. Good point. So the question from Jessica was, if I take these integers and I say 5 is greater than A, will that work? Yes, it will. Now we get to the crux of the matter. Where in the hell does 5 sort with A, right? It makes sense when you have an alphabet. We start at A and we end at Z. That's how we do things with English. But a computer alphabet, and I covered this earlier on, doesn't just have numbers and letters. It doesn't just have letters. It has numbers. It has punctuations, dots and periods, and it has parentheses. It has, math symbols. It has these things. It has all kinds of stuff, right? And all of them fit somewhere in the computer's alphabet, right? So that computer's alphabet is, for our purposes, it's called ASCII. And that started very early on with computers, when they had to assign a number for each different character. And that's what you see when we do this idea. When we say, is 5 greater than A? What the computer does is it says, let me get an ASCII table, right, like this. This one looks really old, we'll use it. So this is actually how the computer sees things. And this is true, by the way. We're not going to go into this in too much depth, but if I look here at A, right, we'll see it, and A is right here, and this doesn't actually tell us the value, but actually, I'm going to skip this one. We're going to find one easier to use. Only because that one required me teaching you something that is way off course. But I do want you to see this because it's definitely a good thing to understand. If I can find one that works. There we go. Okay, this one's good. Okay, so we see the lowercase a, and then we see over here the decimal value for the a is 97, right? And then we see the 5, which is over here, and the 5 is 53. So is 53, what was the question we asked? The question we asked was, is 5 greater than a, right? And 5 is 53 and a is 97. Is 53 greater than 97? No, and that's why we get back false. So if you wanted to know the answer, that's actually, everything in a computer has, every character is assigned a number, always, right? And then what we're doing is we're actually figuring out and comparing those numbers. Okay. So, where did that thing go? There it is. No, there it is. Okay, so we get back to this whole sorting thing. When we sort, we mutate, right? When we dot remove, we mutate. When we call delete, we mutate. All of these things are changing the list that we're working with. So we can also sort here. And now notice that when we sort, let's take a look at this. We have Alice and Ants, and they both start with an A. But which one comes first? Alice, right? Alice comes first. Kenya, why does Alice come first?
I just know that the ASCII order, that uppercases were before lower.
Exactly. So we're going to come down here to this chart, and again, I just wanted to make sense to you with the chart, because it definitely is going to help out. When we look at this, let's take a look at it. A over here is 65, right? Lowercase a is 97. Let's come down here and let's look at the Z. Capital Z is 90, but lowercase z is 122. Capital Z is 90, but lowercase a is 97. That means all of the capital letters come before the lowercase letters. right? So when you sort it, that's exactly what Python is showing you, right? You come back over here to the example, and we see here that all of the capital letters come before all of the lowercase letters. That's all there is to it. It's just computer. Okay, so we have here span equals AZ, AZ. How do we make it do what we want it to do? We can say here that the key equals string.lower, right? And then what it's going to do is it's going to lower, it's going to call string.lower on each different value. So now we're going to be comparing everything, but only after we lowercase it. So let's take a look at it, because they didn't actually introduce this, string.lower. We have something in Python, string.lower, and we can give it something like this, ASDF, and we get that value back, lowercase ASDF. String.lower, right, Evan, HLUG, Evan. Best example ever. And if I call that, I get the lowercase string back. So in this example here, we're providing to Key a function that we can call with each different character we're iterating over. And the result is that after we call that, we're just comparing lowercase numbers, which stops this whole little effect with uppercase coming first, right? Okay, now we're doing this magic ball with a list. So we import this thing called random, right? I think this may be the first time we've seen the import thing. So Python has the ability for, now we're getting into actual like programming stuff. This is, we're moving past basics. Python has something in it called import. Import allows you to call in code you didn't write. So it's a huge thing. We can go import random, and now we have all of these things that we didn't originally have. So how do we make sense out of it? We can say help random, right? Always go back to your help. This is going to tell you what we just got, right? So we got all of these functions here. Get state in it. Well, these are the actual functions here. Gauss, get state, long norm variate, random integer, random range, sample, set state, and you can read about what all this crap does. It's way beyond the scope of what we're doing. But the point here is that now we have integrated the ability within our programming skill set to use code that's not part of the core components of the language. Right? These are modules that we have to add in. So we can use this thing import random, and now we have this message here, and message is a list of all of these different strings. It is certain, it is decidedly so, yes, definitely, reply hazy, try again, ask again later, whatever. So we have all of these strings that we have in this thing, messages. And if we look at it, we get all of them there, right? Make it bigger for the people. We get all of them right back. But now we can say here, what we want to do is we're going to print them out in random order, right? So what we do is we essentially take messages and we call random.randomInt. We're going to get a random number between 0 and the length of the messages minus 1, right? So this is going to give us a number. When I say random, let me call this outside of it, because I think that's a better way to show you this. Okay. When I run this piece of code here, that's not exactly what I was expecting. Random length messages minus 1. Oh, it is doing one. Okay, there we go. I got 2 4s back, and I was like, what in the crap's going on here? Why is it giving me back the same thing? And then I ran it again, and I got a 2. Now it's doing what I'm expecting. This is actually saying I need a random number between 0 and the length of the messages minus 1. Right? So the first element of the messages, when I run messages, the very first thing here, it is certain, this is the 0th element, right? I want to get a number between 0 and whatever number represents this last thing, right? The last thing I can find by doing length of messages minus 1 is 8. So if I do messages 8, I'm going to get very doubtful, which is here. And I want to get a number between 1 and 8. So what I do is I call this. And now I get 8. And if I keep calling it, I get a different number every time. So if I want to select a random message, I can just use that into messages. And now every time I run this, I'll get a different message.
Isn't it between 0 and... is it between 1 and 8 or 0?
0 and 8.
Right, yeah.
Right. So random is inclusive, that last thing. That's right. That's what you get. Okay. Moving on. Okay, so we talked about Python. Python has these really strict indentation rules. And what we're showing here is that when we create a list, the indentation rules are altogether different. They go out the window. When we see this open bracket here, right, the only thing Python cares about is the closing bracket. Normally, Python is very white space sensitive. It cries like a little baby. Anytime you have too much indentation or too little indentation, it flips, doesn't know how to handle it, because it says all of that white space is significant. That's how I determine what a block is. In this case here, right, the second you start a list, until you end that list, Python doesn't care about the white space. It essentially is the same as if you put it all on the same line. Does that make sense? Okay, let me show you here what I'm talking about.
Yeah, and the words make sense. The logic does not.
I can explain the words. I can't explain the logic.
Yeah.
It's just Python, right? What I mean to say is that if I had all of this stuff on the same line, right here, all of this was on the same line, and there wasn't all of these spaces before bananas, it would do the same thing. Does that make sense to people? So it's just saying that the rules are relaxed. And the same thing is true about anything that begins with a parentheses. So when you start something with the parentheses, you can do spacing however you would like. And Python doesn't care. Right? Okay. Moving on. Okay, I think we're going to pop back up here. 1 hour to go. Name equals Zophie, right? So we have this name, we set it to Zophie, and now we're using these, we're indexing into Zophie. What do we get when we, first thing, does anyone remember what a string is in Python? A string is a group of
characters,
right? So because it's a group of characters, and you can think of a string like a container of characters, we can get individual characters using this notation. So the 0th character of Zophie is Z. The -2 character of Zophie is -1, -2, I. 0 through 4 is going to be Z, O, P, H. Right? Because the 4th element is up to but not including the I. Right? Does that make sense to everyone? That's all that we're showing here. Okay, we have the in and the not in. They also work the same way. There's nothing special about any of this stuff. Mutable and immutable data types. We already talked about it. A list is, which one?
Mutable.
Mutable. Okay. It was Danielle? Why is a list mutable?
You can change it. You can change what its value is without just reassigning a new value.
That's exactly right. Tell me 2 methods we can change it.
Append or insert.
Boom. Can anyone name a third?
Delete.
Del. Delete or remove.
Del is one. Okay, but concatenation doesn't change it. Append changes it, remember? Concatenation returns something new. Does that make sense, Peter? Okay, but there's one other method we saw. Right? Sort. Sort changes the list. It actually resorts it. Okay, so we come down here and we're seeing it, and now we have this name, Zophie is a cat, and we can say new name, and now we're taking part of Zophie is a cat, and taking some more parts of Zophie is a cat, and now we're actually saying Zophie a cat, right? So, but the new name, Zophie the cat, we're replacing a with the. Does everyone see what we're doing? We take all of the stuff before the space, Zophie, and all of the stuff after the space, cat, and we just say Zophie, add the, and then add the rest of it. Okay. So here what we do is we're taking eggs and we set it equal to 1, 2, 3, eggs 4, 5, 6, and we say eggs equals 4, 5, 6. What did I say? What happens to a value after you assign over it?
Gone.
It gets copied.
Totally gone. Gone forever. So eggs 1, 2, 3, totally gone. Eggs equals 4, 5, 6. That's the new value. Value of eggs is going to change to another, an entirely new. Yes. Okay. If you wanted to actually. Okay. Cool. So eggs equals 1, 2, 3. Right? We have this thing del eggs 2. What element is this going to remove? What's in the right shirt? What's your name?
Travis.
Travis. What is it going to remove?
3.
3. 3's out of there. Next to Travis. Our friend. Yeah. One more time. James. James, what is it going to remove?
So
It's going to remove the 2, right? So here's the thing. When we remove from the end of the list to the beginning, we're okay. We move from the beginning to the end, something different happens. Because if we remove the first element of that list, you have to remember that all of those other elements now move back 1, right? Okay. Eggs.append 4, eggs.append 5, eggs.append 6. We're adding 4, 5, and 6 to the end. Okay. Moving on. Now we have one more data type we're going to introduce, and it's the tuple data type. The tuple data type is almost identical to lists except in 2 ways. First, tuples are typed with parentheses. We use parentheses instead of square brackets. And for example, enter the following into the interactive shell. Eggs equals hello, 42, 0.5. Eggs 0 is hello. This behaves just like a list so far. Eggs 1 to 3 behaves just like a list. Length of eggs equals 3 behaves just like a list. So far, it's the same thing. Now here's where things change, right? A tuple is not mutable, right? So we talked about a list being a mutable type. We can do all these cool things to it. The tuple, you cannot. Here we're trying to reassign the first value, right? Which would be this. They're trying to make the 42 a 99. But Python is going to come back and say, the tuple object doesn't support list assignment. It doesn't support item assignment. And it doesn't do that because the list is immutable, not mutable. I mean, I'm sorry, the tuple is immutable, not mutable. That's what I meant to say. Whereas the list is. And you won't, I hesitate to think like when you would use a list, you would create one. Oftentimes things will give them back to you, you know. So if you do something like interact with a database, you'll get back a tuple because what they want to show you is you can't change that. It's a record from a database, right? So you don't have that ability to add things to the end and whatnot.
That would be an example, a read-only function, or?
A read-only function, or when you update a database, you'll call an update method. You don't change the list, right? You don't change the tuple. You actually say, I want to update this with, a different type of thing. You make a special call. So in those types of cases, you want that type to be read-only. You want it to be immutable, right? Converting types with a list and tuple functions. Here we say tuple equals cat dog 5, and now what we're doing is we're giving it a list and we're creating a tuple. So in this context, what does this look like? Does anyone see this and say, oh, that kind of looks like these? Give me an example, man. You got it.
You mean a list within a list?
The tuple thing.
Within a tuple, or a tuple with a list as its one item.
Yes, but doesn't this kind of look like the int and the float and the string thing? Where we give an int one type of thing and we get something back? Let me show you. Let's come back here, let's make this all come home. If I say int 5, what do I get?
Convert the string 5.
Aha, we convert the string 5 to integer 5, exactly. Right, if I say string, and I want to say something like 5 plus 10, what is that one going to do?
Give you a string of 15, right?
It's going to give me a string of 15, right? We call these type constructors. That's actually the technical name for them. So these are actually type constructors. You can give string any type, and it's going to return to you a string if it can. You can give integer any type, and it's going to return to you an integer if it can. Likewise, we have this thing called the tuple type constructor, right? And a tuple type constructor can take a list, right? So we can say, oh, you've given me this list, I'm going to give you back a tuple. So int, string, tuple, and float, they all kind of have the same look and feel to them, right? You give them one type, they give you back another type. I just wanted to draw that home. There's also one for list. So we could say list, tuple, 1, 2, 3. Right? Let's take a look at that one. That one the book didn't go over. That's kind of cool, right? Now we have this thing on the inside, 1, 2, 3. Kenya, what is 1, 2, 3 right here?
That's a list.
That's a list, exactly. By the way, that is the worst highlighting color I've ever seen.
Yeah.
Yep. That's kind of more like a low lighting color.
Yeah, what in the, who was thinking of that? That UI UX guy should be. No, okay, yeah. So this is a list, and then when we call tuple, what do we get? Kenya? That's it. And then we call list, what do we get? Isn't it simple? So we construct a list with these brackets, right? And then we convert it to a tuple, and then we convert it back to a list. This is a great way to spend a day, right? We're not doing anything at all. But that's something kind of cool. So we have a method of creating a list with this type constructor, right? And I can say list 1, 2, 3, and now I'm giving it a list, and it's returning me a list. In the same way that I can say string, and I can give it a string, and it's going to return me a string. Neither one of these two things are more complex, and they're actually really the same thing all around. Let's look at this. I can create a string by quoting a string, right? So that's how you create a string. You don't have to give it to something called string. You put quoting marks around it, right? Single quoting marks or double quoting marks. And then you get back a string. You can create a list by doing brackets, right? You can create a tuple by doing parentheses. And all of these things have a type constructor, right?
Where would you use a tuple versus a list?
When you want it to be read-only. When you want it to be immutable. Okay. So, references. Have you seen oh, by the way, let's say you want to say, oh, what kind of cool things can I do with the tuple, right? How would we figure that out? Help. You can say something like help, and you can do something like 1, 2, 3. And I think that'll work.
Nice.
Right? And the reason why I said I think it'll work, and I'll be honest with you, because sometimes I don't know what the hell's going to work and what's not, and I'm doing this all live. So I was thinking to myself, I know this will work to find out the help for an array, but I'm not sure this is going to work, but it does. And I just didn't want to risk it. So yeah, and you can do the same thing for a string. So all of those, when you want to find something out, you can construct anything and just throw it at help, and it'll do what you want. Okay. So we have now references. As you've seen, variables store things, strings, and integer values. Enter the following into an interactive cell. We already know what's going to happen here. We set cheese equal to spam. Spam is 42. Then we set spam equal to 100. Now here's the catch. Spam equals 100, cheese equals 42. When you reassign a value, you don't reassign everything you set with it, right? We should know that at this point. And it's for the same reason the def thing worked earlier. If I say A equals 10, right? And then I say B equals A, and then I say B equals 42, what does A equal? 10. Right? Now, let's say if I do this. Def, right, let's say here, my function, right? And then I'm going to say it takes a variable called C, right? And then I'm going to say C equals 55, return. Now I'm going to call my function, right, with A. What is A going to be equal to?
55? Oh, sorry. A is not equal to
10, right? And it's for the same reason in both of them. That's where I want you to bring it all home. I want you to see it. That when we set a value, right, it doesn't change everything that you set with that value. Because Python is going to copy it each time, right? So when I say A equals 10, B equals A, I am setting B literally equal to 10, not equal to A in any way, shape, or form. It's going to look up A, figure out it's 10, and that's what B is going to be set to. Same thing right here. When I call my function, and I give it a variable, right? And I say my function A, I'm giving my function the literal value A. It's going to take it, and I'm going to be setting a new variable that has got 10 in it, right, to 55. And I'm just going to be returning. That new variable goes away then. Right? I didn't write anywhere outside of that function. Okay. So here's a good question for you. For everyone who paid astute attention, I'm not sure that's the right way to phrase that. For everyone who paid attention to Ed's lectures on function, what if I actually wanted to change the value of A from within a function? Or I wanted to use a function to change the value of A. How would I do it?
Use a global?
That's one way to do it. That's a horrible way. Does anyone else know how to do it?
A function would return a value that it's assigned A.
Aha! Bada boom! There we go. Team Media gets a point. They get a lot of points anyway. I'm always thankful for the media guys. Because that's something I don't like to do, and they do it all for me. And I almost don't even have to answer questions. It's wonderful. So let's take it here, right? We're going to paste the same thing again. Def my function C. And I'm going to say here C equals 55. And then what I'm going to do is I'm going to say return C. Right? Now I have A up here. A is still equal to 10. If I want to set A equals to 55, what do? A equals my function A. Just like that. Now what does A equal? Boom. We have an explicit assignment. That's what Python wants. Okay. So, we're done with this. This is... Okay, we're going to go over weirdy. So this is passing references. Okay, one other thing we're going to go over. The idea of the immutable type, right? The type itself, right, doesn't store copies of all of its values. What it stores is references to those values. So when we say the thing is mutable, that's what we're getting at here. When we have something like, let's take the same function, def my function, and then let's say, let's give it a different name entirely, new function. And then what I want to do is I'm going to say it has a variable, let's say x, right? And then I'm going to say x0 equals test. And then I'm going to say return. Now if I say a equals 1, 2, 3, and now I call my function on A, I mean new function rather, jeez. New function, A. What is the first value of that going to be? This is something new entirely, and this is the catch. This determines whether or not we're talking about mutable types or immutable types. Test. This is the one exception to these rules. When you talk about containers and you pass in a container, the whole container doesn't get copied, right, with the list. You're getting essentially, you know where the container is, and you can actually modify that type. So the container is mutable with the list. When you pass the container, the other guy's going to get a reference to it, essentially, and he can modify the things inside and do whatever he wants. So that's one of the attributes of this immutable, or this mutable container, a list. Okay, and this is just something like people, you may ask, like, well, when do you have to memorize this and what are you going to do with it and whatever? These are just part of Python, right? It's just part of like the burden of learning a new language. There's no general rules about why one way is better or not. If I say something like A equals 1, 2, 3 like this, now I have a tuple. What happens if I call new function with that tuple? Anyone want to take a guess at what's going to happen?
Exception. Error.
You get an error. Because it can't mutate it. Right? Okay. So now we have this thing, we just saw this ability to create a function that mutates the elements inside of its container. You pass it a container, and it opens that container up and it mucks with it. It can add to the beginning, it can add to the end, it can change the elements inside of it. We can understand all of these things that it does. What if you don't want to do that? Right? I said the container passes by reference, which means that thing that you pass it to knows where it's at, knows how to modify it. What if you're writing a function and you don't want to change that guy's array, that guy's list? You don't want to mess with it. How would you do it?
Copy it.
You would copy, right? So in Python, we import something called copy. Now, who wants to take a gander at how we figure out what this did and how we can figure out more information about it?
Help copy.
Help copy, and now I can see all of the cool stuff that this does, right? In this beautiful document. There are only two functions it provides, copy and deep copy, right? So you'll see this term everywhere. We said a list can contain a list, right? If a list contains a list, and lists are mutable, then if I make a copy of a list, right? Will that include that inner list or not? It won't. That's why we have deep copy. Right? So there's the difference here is that deep copy is going to copy the list and all of the things inside of it. Even if they're lists, you're going to get new things entirely. Right? Whereas copy is only going to copy the very first thing you give it. It's not going to do what we call recursing down and making individual copies of it. Let me show you why this matters, right? Okay, so we have copy.copy, right? And I can give it something like, let's create something new. A equals 1, 2, 3, and then I have 4, 5, right? Or let me put it at the beginning so it's easier. 1, 2, 3, 4, 5. There we go. Okay, so now I have a list, and it has, as its first element, a list with a 1 and 2. And then it has 3, 4, and 5. Right? I'm going to show you both of them right now. If I do B equals copy.copy A, right? Now, if I look at B, you can see that I have 1, 2, 3, 4, 5. And if I change a value on B, like the last value, to 10, right? And I look at B, you can see that I have a 10 at the end. Now, if I want to look at A, you can see I have a 5 at the end. Because I have made a copy of A. But you see this 1 and 2 here? I made a copy of a reference to it. So if I go B0, 1 equals 100, right? And now I look at B, I have 1, 100, 3, 4, 10, right? So I have changed the 2 to 100 in B. Now if I look at A, I've also changed it there. And this is where deep copy comes in. So if I say C equals, right, copy.deep copy, A, and then I come up here and I pull the same card on C, and I change that value. Now if I look at C, I have 1, 0, 3, 4, 5. I've changed it from 100 to 0. But now look at B, or look at A, rather. I didn't change it on A. You see that? Does that make sense to everyone? Deep copy is going to go into that list, and it's going to say, I want my own copy of this. And if that's a list, it's going to go inside it and say, I want my own copy of this. And if that's a list, it's going to go inside that. And it's going to keep doing that infinitely. Deep copy is going to return to you a whole new structure for you. And you can play with it any which way you want, and it's never going to manipulate anyone else's structure. Right? Copy only goes in one level. It doesn't keep going down. So a deep copy goes further down. It'll say, okay, the first element is a list, I need my own copy of that. And if there's a list inside, it's going to go deeper. And every time it's going to make its own copy of whatever's inside. Whereas copy doesn't. Copy just says, I'm going to copy all these things and then I'm done. So it just depends on what you need to do, right? Deep copy is usually more work, and it gives you your own copy of everything. It also takes more memory, because every time you run it, all of that crap is getting a copy. Okay. And we have now learned copy and deep copy. And the summary. Okay, we're at the questions. We're going to finish, I think, early today, once we take 30 minutes for these. How many do we got? Well, we got a lot, maybe. Okay, so let's start off. Which direction want you guys want to start? Kick it off, Brad. What is that?
List.
You got it. It's a list constructor. Brackets are a list constructor. Moving on. How would you assign the value hello as the third value in a list stored in a variable named spam? How would I assign the third value, the 6? How would I assign this to spam? Wait, assume. Yes. Okay. So if spam equals that list, how am I going to change the 6 to hello? That's exactly right. Spam to hello. Because you're going to get the second index into spam. You want to set that to hello. For the following questions, let's just say the spam contains A, B, C, and D. Okay. What does spam int 3 times 2, 4 to 11 evaluate? Why is that?
It's because it's a, well, it's No, because it's
No.
turning the string or
That's the integer.
using a string operation the first thing.
3.
That turns into 33, and that turns into the integer 33, then it divides by 11, which turns it into 3, so...
33.
Let me ask these questions, right? It's not an error. I can already tell you that. I think it's just a stupid example.
It is.
So I just want to be clear of what the issue I have with it is. What is this going to return, Kenya? Because you're going to get it right. I know it.
That's gonna be 33 number.
33 is a number. That's exactly right. Okay. We have this divided by sign. I covered this in the first class. Does anyone remember what I said it did? Because we don't
Floor
see
division?
Floor division, right? That's good. So what is floor division going to do? If we have 33 and we floor divide it by 11.
It's just going to divide like normal.
So what are we going to get?
3.
3. So we're going to have here in this, we're going to get 3. So what is spam? What's the third index of the third element of spam? No. What element has? Jesus, this is.
What is element 3?
You know, and I had my own stupid way, which was the normal way of doing this, and then I tried to take these improvisations. Okay, what element is indexed by 3 in spam? Spam 0, 1, 2, 3. D. That's right.
Evan, isn't the outermost int casting unnecessary?
Totally.
Because I think integer division gives you an integer.
Yes, it is unnecessary.
I think if it gave you a float, it would be necessary, right? Or would it choke
No,
on
because
that?
this is always going to return an
Yeah,
integer.
okay.
It's not actually floor division. That's what people call it. It returns an integer. Okay, it's a good point, Robert. So, what does spam -1 evaluate to? So, exactly. 1 point for person. What does spam 2 evaluate to? Who wants to hit that one off? Mark?
T doesn't have the list, but 11 ABs for the following 3 questions. Wait, the list.
It's right up here.
And
Spam contains 2, 4, 6, 8, 10.
So wait, it's gonna be no list, but not under attention.
Those are the following
So
questions.
it's going to go from 0
The following questions
Question.
contain-
So 2, 4,
Following
3.
3 questions contain the A, B, C, and D. That's what
Oh,
I said.
okay, yeah.
Yeah.
So okay, then ABC then.
There, so A,
And
B, up to but not including the second element. Right, so 0, 1,
You're right.
up, so A and B.
A and B.
Okay. What does, we're back to bacon. Jesus. For the following 3 questions, let's say bacon contains the list 3.14, cat, 11, cat, true. Cats and bacon. I don't know what's wrong with this guy. Okay, he's obviously a cat person. Bacon.index cat is going to return what? It's going to return the first thing that has cat, right? Which is what? 1. Susan, you got it. 1. What is bacon.append 99? Susan.
It just adds the number 99 to the end of the after true.
Exactly. Got it. Okay. Zach, what does bacon.remove cat make the list value?
Takes up the first cat?
That's exactly right. The first one. Explicit and right. What operators for list concatenation and list replication? Jessica.
You do this, please. Read it again. What are the operators for list concatenation and list replication?
Concatenation.
That's the plus sign, right?
The plus sign. List replication.
The multiplication sign?
Exactly. What is the difference between append and insert list methods? Okay, so who wants to get on that one?
append adds to the end, and insert you can give the location without giving the location of it within the list.
That's right.
Insert.
That's right.
The,
And it inserts
the
it.
index. You give index.
That's right. Right. Exactly. It's going to insert it whatever that index is that you give it. Okay. What are 2 ways to remove values from a list? Marcel.
Del and something else.
Dot. So if I have a list and it has foo, bar, baz in it, and I want to remove foo, I can call list dot remove.
Remove.
Remove, yeah. List dot remove. Okay, well here, I'll let you make it up. If you forget what it is and you want to find out, how do you find out?
Help.
And how would you invoke it?
Because you don't know if it like help, and you can do like help parentheses, just make sure that you know, or you'd like to go help remove or help.
Well, let me show you here. I have help, and I want to find out what is that method that you forgot. What am I going to provide help? Let him get it.
Wait, say it.
Okay, I want to know how to. I say, oh shit, he said it's dot something, right? List dot something.
Yeah.
How am I going to find out what I can have here?
Help that.
Well, I would do help in a list, right? You got to give it a list.
Oh.
So you give it a list, and it's going to tell you all those methods on that list, right? But the thing is, you got to give it the type, because you want to find out what kind of method on that type you can call. So if you give it a string like that, you're going to find out all the methods for string. You give it brackets like that, you're going to find them for lists. And you give them parentheses like this, you're going to find them for tuples, right? So you got to provide something for it to work on. And remove would be valid, but remove isn't a function. So you could do help length like this, right? And you're going to get information back about length, because length is a function. It doesn't sit on a list. You can't say something like a equals 1, 2, 3, a dot length. See that on the board?
Yeah.
That doesn't work. So if you want to find out for length, you would just provide that function name. But when it comes to finding out all of the methods for the list, you got to provide it that type. Yeah, you got to give it something, you know, help, and then maybe empty brackets, something. Yeah. Okay, very cool. Moving on. Next question. How do you type the tuple value that just has the integer 42 in it? Hit it up, Zach. How do I get a tuple with a 42 in it?
42 or parentheses 42 comma close parentheses.
Like this?
With a comma after the 42.
With a comma after the 42, like this?
Yeah, for some reason I think that works. No, it doesn't work. Well, wait, is it? No? Okay, never mind. That's what I put in my answers.
Okay, so you don't use the comma afterward, right? Because if you use the comma afterward, then it's essentially the same thing, I believe, and I could be wrong on this one. Nope, I am wrong. Yeah, that's a good question.
So it looks like when you do just parentheses 42, it's taking it as like arithmetic parentheses, whereas if you have the comma, it's actually giving you the tuple.
That's right. That is what's happening. So how? That's it. So
it's actually noted in the text. So you need the commas so you can basically force the evaluation context to not wholly fit you are just doing mathematical parentheses.
So if I do tuple 42 like this, is it going to return to me the thing with the comma in it? I mean, like this. It does. Aha, you're right. No, you're right. I'm wrong. If you do tuple 42 like this, it's going to take the list of 42 and create a tuple from it, and it has the comma there. So you're undisputably right, and I am wrong on that one.
So basically, you need at least one comma.
Yeah, you need one comma. That's a good rule. So there we go. That's the rule. The rule is you need to have a comma if you're going to create a tuple.
That's a one-dimensional tuple or a two-dimensional?
One-dimensional tuple, which is why that's such a stupid syntax. I agree. I didn't write Python. I just use it.
In Python, it truly took some time for me to get comfortable with the idea of more than two elements in your tuple also.
Yeah. Okay. How can you get the tuple form of a list value? Okay. Pretend like you didn't just see me type in a terminal. Someone shouted out at me. I gave it to you. What is taking you so long?
Tuple list.
That's it. Tuple parentheses list. Okay. What variables contain list values that don't actually contain lists directly? What do they contain instead? Variables that contain list values don't actually contain lists directly. What do they contain instead?
References to the list?
Yes, that's right. That's exactly right. References the list. Okay. So when we pass the list to a function, right, it didn't get all of that crap inside of the list. It got the reference to the list. And that's why we were able to add things at the end of that and remove things at the beginning of it and rewrite it, right? When we passed variables into a function, we couldn't change them because those variables were immutable, right? So it makes a copy of them. But when we passed the lists into a function, we were able to mutate them from within the function. Remember, let me see if I still have it where we did it. Right up here. Right. Maybe up higher. Where did we do that? Right here. We created this function called def new function, remember? And we set in it x0 test. And then what we did is we said a equals 1, 2, 3. And I provided a to new function. And what did it do? It overwrote the first value. Wrote it as test. Right? So it was originally 1, 2, 3 right here. And then it became test 2, 3 after I provided to the function. Because that a didn't pass 1, 2, and 3. It passed the location of a. And then the function actually manipulated it. Changed it. Okay. So, number 17. What is the difference between copy and copy.deep copy? Who wants to hit on it?
Copy, if you have a list, copy the first item of the list, and deep copy of the entire thing.
Yeah, that's kind of, but there's a better way to say that. I get what you're trying to say, and I think you're on the right path.
Well, it seems like it's like, isn't copy like, we would think of like creating a link to something like a symlink and copy is what we normally think of as copy?
No.
So deep copies lists that are contained inside the list, and copy just copies values that are contained.
So lists are references, right? That means that when you pass a list around, you're getting a location in memory, in the computer's memory, right? When you make a copy of something with a list in it, you could either there's two things you can do when you say copy. You could either make a copy of that reference, which is pointing to the same place, or you could make a copy of all of that crap at the reference, right? So if you make a copy of the reference, then whatever you're passing to, they have the reference to modify and change all of those original values. If you say copy.deep copy, though, it's going to say, hey, whoa, this is a reference. Let me go through it, find out what it points to, and copy all of that stuff. So I have my own local copy of it, right? So exactly, deep copy goes down further, recurses into that list, makes copies of everything. Okay, practice projects. For practice, write programs to do the following tasks. Comma code. Say you have a list value like spam equals apples, bananas, tofus, cats. Write a function that takes a list value as an argument and returns a string with all of the items separated by a comma and a space, with and inserted before the last item. For example, passing the previous spam list to the function would return apples, bananas, tofu, and cats, right? There, your function should be able to work with any list value passed to it, right? So we pass to it a list of apples, bananas, tofus, and cat, and then it should return it with commas and the word and before the last item. Okay, so how are we going to do that? Well, I'll tell you how I would do it. All right, let's go ahead and go through it. We can say here def. Well, let's take a look at something first. Let's take a look at the man page for the list, right? So we're going to say help, and I'm going to give it an empty list, right? Now what I want to do is I want to find something that I can have that will join, right? So what I really want is to join that list together. I'm going to look here and I'm going to find something inside of it. I thought I would find something inside of it. Let's see something else here. It may only be in the... Oh, okay, I know what they're... Okay. So let's do this. Def join and comma, right? And I'm going to pass it a list. And now what I need to do here is I need to iterate through that list, right? So I'm going to say final string equals empty string. And then what I'm going to do is I'm going to say for I in length of L minus 1. This is no. Where's my function? for I in length of L minus 1. We're going to say output plus equals length. So what I'm doing now is I'm creating an output string. I'm capturing the index for it. And then what I want to do is I need to have, the trick here is that the second to last one, right, needs to have the and instead. So I'm going to say here, if idx equals the length of L minus 1, break.
You colon that.
Yeah, I don't need to colon for that. And then what I'm going to do is I'm going to say output plus equals again, a comma, and then I'm going to add to it length L, and then minus 1 for the last element. Okay. Joining comma. Here's the example call for it. It calls for spam bananas, tofu, and cats.
I think the if statement's going to need a colon.
Okay. So I'm going to go run, scratch 3. It's still giving me a problem. Output equals empty string for idx in length L minus 1. Line 13. Oh, the object is not iterating. Why is it saying that?
Is len L minus 1 an integer? It's not an iterable object?
Let's come right here and say here.
So,
what's up?
I was gonna say you probably needed a range in there.
That's the reason. Yeah. Okay, good catch. Yep. Run. There we go. Now all I have to do is print it. That is not working. Oh,
You need to return?
Return the value.
Yep. Okay. Apples, bananas, tofu, cats. So what we're missing here is we didn't do a space, right? Because we have to have the space for it. And then what we also have to have is the comma. So, comma, and then this is supposed to be not a comma, it's supposed to be and. So, run that. Except this should say like that. There we go. Run, scratch 3, apples, bananas, tofu, and cats. Switch the order on this, and we're done. Hopefully.
Well, if you're good with an Oxford comma, yes.
Yeah, that's a good point. So what we're
I don't use commas.
Is that a new pineapple pizza versus normal pizza?
So what we want to do here is we want to add the comma at the
I
end.
prefer that, actually.
To the pineapple, yeah.
So we could here, let's just do this. If idx is not equal to 1, then what we're going to do is go output plus equals to idx plus comma. No, we switch it the other way. There we go. Okay, otherwise, else, output, output plus equals to LIX. There we go.
You need comma on there, or colon on the L's.
You're out, if the next line, the indent got messed up.
Output one.
On the output line, or the
one
next
down,
one? Yeah.
One down.
Oh, shouldn't be here at all, right? No, okay, that should be,
Yes,
yes.
no, yes.
But isn't that where it was?
You knocked one space out of it.
Oh, okay. Apples, bananas, tofu, I'm done with this.
So, yeah.
What I want to do is a list comprehension. I just don't want to show how a list comprehension works. Okay. Let's try this one here. Not equal to 1. So then this is going to add them. If we do this, right, it's going to come, you're going to have, the first one is going to have something, right? It's going to have comma, item, comma. That's not going to work.
This is when you just settle for the Oxford comma.
Yeah, it's just gonna settle.
If your logic gets a little simpler, you let that begin.
So, wait, first thing, did this thing even allow the Oxford comma?
I think it specified it, right?
It actually shows it.
Yeah, so it even shows the Oxford. So then that's the reason we're just wasting a lot of time on this. Okay, it's gonna be
But
this.
it's possible to do.
What's up?
It's possible to do.
It's possible to do. It's just gonna take a lot of time. It's like what I want to do is just like this. I just want to say, x plus comma, for.
Are you trying not to use the Oxford comma?
I was trying not to use the
Because
Oxford
the
comma.
traditional way is to assign a separator variable to nothing, and then to prepend the separator variable to whatever you're expanding in your loop, and then inside the loop reset the separator variable to the comma after you've done the append.
Yeah, that's
I think this
better than what I did.
No, that's wrong, because you're putting it at the end. You can't actually skip so easily. Then you'd have to detect the last one.
I think this will work.
Well,
I think this will be
sure if you want to split the list, but that's not the traditional way to do it.
Yeah, but it's the Python way. And where's my damn?
I'm not so sure this is the Python way.
It's good enough. It's good enough for me. I'll put it to you like that.
And that is the Python way, just good enough.
Yeah, right? Okay. There we go. 4in length. There. So if we ignore the Oxford comma predicament, we get it. That's easy.
That fails if you have a one-item list.
What's up?
That fails if you have a one-item list.
Go away. I actually, what is it going to do if we have a one-item list? Let's take a look at it.
It'll print and apples.
Yeah. So this is definitely a catch for it. Or no, it'll just die, huh?
Oh, I guess it's dying on the slice above.
Yeah. So here, we need to say here, if length of L is not equal to, or less than rather, 2.
Just do a try catch.
Yeah, just do a try catch.
Abusing exceptions for fun and profit.
There we go, yeah.
You just couldn't use a reassignable separator, could you, Evan?
No, I'm not. I'm not going to do it because it was your idea. There we go.
You got the condition backwards.
Can we use something like the zipper?
If the length of L, okay, yeah, is greater than 2. There we go. Greater than 1. There we go. This handles the ed case. So we have now created something that ignores the Oxford comma situation. And what we're doing now is, let's go through it. We say if length of L is greater than 1, right, this is the ed case. Then what we're going to do is we're going to say for I in, and we're going to take all of the values in L from 0 until but not including the last element, right? Then what we do is we say output plus equals to I plus the comma, right? So we're going to give each different element followed by a comma and a space, right? And then when we're up till the last element, we're going to say output plus equals to and then the last element.
I hate to throw in one more ed case.
What's the last
that
ed
will
case?
print out apples, comma, and bananas instead of properly suppressing the comma when you only have 2 elements.
That already puts you in here.
Restate what he said.
Apples and apples. I'm done because you never got comprehensions it is.
Can we use zipper?
A zipper?
Yeah, so take 2 lists, one with only commas, and then
That's another method. You can do that if you want to live code that one. Have at it. I am done not using list comprehensions in this problem. There are cool things. Let me tell you here. When list comprehensions come up, let's see here. I bet that there may be. Let's see here. Automate the boring stuff.
Make the boring lists with Python.
I don't even know that they.
It says at the end that they're specifically not covering it.
What does it say that?
They were in. Shit, I don't know. It's the search. I think it's towards the beginning, but my PDF reader sucks. Yeah, trust me.
That's so fun.
So on the line below, instead of I, don't you want L?
Yeah, you want the last
element
slice
minus
of
1.
L minus 1.
Where are we looking at?
The line below your cursor. Well, where your cursor was a second ago. Go down one more from the one below that.
That was installing. When you're
That
adding
one.
the and in, you need
No.
to add the and the last element of I, not the first.
Oh, shit. Okay. So,
Yeah, because
the one below that, Evan.
This editor is killing me. Just don't use the
but this one.
L-1. There you go.
that should give you apples and bananas.
No, that'll give you apples, comma.
Well, it
and
gives you the
bananas.
commas, but
Apples and bananas. There you go.
There's this non-Oxfordish comma between your and.
Yeah, I can remember Jet.
I
This is one way of putting it. The Oxford comma one I think would have been more interesting, but that one was being a pain in the ass.
So, but is this going down from that basement?
There's a method inside of Python. I'll give you like a little teaser here about what they're not going to cover. So you would do this if you did.
You can remove it. You can put the voice dialer.
Yeah, under conventions at the beginning, it says they're not going to do that.
Comma in a live present.
No, I'm not saying that I don't.
But how else will people take you seriously?
So if we were to do this, it would be X.
thank you for appreciating that. But the example did include
Yeah.
No.
I need to make a lot of writing.
As it points out, there is one, if you only had 2 elements, it looks weird because you don't typically use a comma with that.
Yeah.
You might have wanted to things that are conceptually
Well, I think it was under settings.
Yes, for example.
Settings and I don't know what else.
Bananas, mac and cheese, and Doritos.
Yeah, it's
If you're using that in real life, your language is probably too complex to dumb it down.
No, let's mash up as many languages as we can because English always has one more.
You read that line about English, this is borrowed from other languages. So much as the dark alleyways, rifles in their pockets, look very useful.
I too read.
Actually, not that educated across that line. My daughter.
Yeah.
Yes.
So you can't even use the string constructor in Python.
You totally can!
Returns the brackets inside of it, which makes it even more thin here. So the question is, do you want to flat out have
I could provide you a Java solution to this problem.
I have a lovely Python solution.
Usually
Well, yeah,
block
that's
numbers.
you can make it